In this video, we are going to go over a couple of rules/formulas for derivatives, and then we are going to do a couple of examples showing how they can make solving derivatives so much easier. And so let's go ahead and dive right in. These are the first 7 derivative properties that you need to memorize. There will be a lot more down the road, but for now, this is it. And don't get confused by the d over dx. It's the same thing as dy dx, y prime, f prime of x. It's all the same. Don't let it confuse you. So property 1, the derivative of any constant is 0. So the derivative of 5, 5,000, negative 12, 14, it's all 0. Second property, this is called the power rule. You will use this one so often. The derivative of x to the n equals n times x to the n minus 1. So the derivative of x squared is 2x. The derivative of x cubed is 3x squared. And I'll show you more examples of this in a bit. But for now, just know that the power rule, x to the n equals n times x to the n minus 1. Property 3, the derivative of x equals 1. That's pretty self-explanatory, right? Not much to say there. Property 4, the derivative of a constant times a function equals a constant times the derivative of that function, right? We saw this in the limit properties. And again, I'll show you some examples, but for instance, the derivative of 2x equals 2 times the derivative of x. Property 5, this tells us that we can distribute the derivative over a sum or difference. So the derivative of f of x plus or minus g of x equals f prime of x plus or minus g prime of x. And now don't get confused with g prime of x. It's still a function. This is just showing that it's separate from f of x, right? It's basically the same thing as f of x though. So don't let that confuse you either. So you can distribute a derivative over a sum or a difference, like you could a limit. And again, I will show some examples of this in a minute. Property 6, the derivative of sine of x equals cosine of x. Not much to say there. In property 7, the derivative of cosine of x equals negative sine of x. Again, not too much to say there. You just got to memorize them. Let's do some examples. The derivative of negative 2x squared plus 3x minus 6. Okay, so we know that we can distribute that derivative over the sum or difference. So this equals the derivative of negative 2x squared plus the derivative of 3x minus the derivative of 6. And now let's tackle these one by one. So the derivative of negative 2x squared, we know we can pull the constant outside of the derivative. That's one of our properties. So that equals negative 2 times the derivative of x squared. And hey, look at that. That's the power rule, x to the n. So we know that this gives us negative 2 times x to the 1, or just x. So that is negative 4x. So the derivative of negative 2x squared is negative 4x. And now, the derivative of 3x, again, we know we can pull the 3 outside. So 3 times the derivative of x. We know that the derivative of x is just 1, so this is just 3. Finally, the derivative of 6 is a constant, so that's just 0. Now, we add all these up, right? Negative 4x plus 3 minus 0, which gives us negative 4x plus 3. And that's it. We're done. Not that bad, right? So let's pause for a second and let's take stock of what we did. So we had this function, negative 2x squared plus 3x minus 6, and we wanted the derivative of it. So we broke it into pieces because you can distribute the derivative over a sum, and we said, okay, so let's just take this apart piece by piece. What is the derivative of negative 2x squared? Pulled out the negative 2, the derivative of x squared, that's the power rule. That's one of our properties. Derivative of x squared is 2x. So we multiplied that through, got that part, and then we looked at that middle portion, 3x. Well, we pulled the 3 out because you can pull a constant out of a derivative, and so it is just 3 times the derivative of x. So just 3 times 1, or just 3. Okay, I got that. And then finally, minus 6, the derivative of 6 is just 0, right? Because it's a constant. 6 is a constant, so the derivative is 0. And then we just added each of those individual pieces back together to get negative 4x plus 3. And so if you get comfortable with what we did here, breaking things apart through sums, breaking things apart, pulling out multiplying factors, pulling out constants. So if you get comfortable with that, you'll be able to solve these limits so quickly, right? Because think about if we did this using our definition of the derivative. It would have taken so long, and you would have been there would have been so many opportunities to make an algebra mistake. This is way faster and way easier. So these are really just a bunch of shortcuts. So get comfortable with them and you'll be good to go. Let's do one more example. So this next example, find f prime of x where f of x equals 1 over x squared plus sine of x. Okay, so how do we do this? First, we distribute it over the sum. So the derivative of 1 over x squared plus the derivative of sine of x. Now, 1 over x squared, we don't have a fraction rule, right? This isn't like limits where you can take the derivative of the top and the bottom. We will get a fraction rule later, but for now, we don't have one. So what can we do? How can we use what we know to take this derivative? So here's how you do it. And you'll do this kind of trick a lot. So be able to recognize it, right? 1 over x squared equals x to the negative 2. So we can rewrite that equation up there as the derivative of x to the negative 2 plus the derivative of sine of x. Okay, so let's do this bit by bit. What's the derivative of x to the negative 2? So that's the power rule, right? X to the n. So that is negative 2x to the negative 3, which equals negative 2 over x cubed. What about that second portion, the derivative of sine of x? Well, that's just straight from our properties, right? Derivative of sine of x equals cosine of x. So we put it together, and we get that f prime of x equals negative 2 over x cubed plus cosine of x. So take some time and really make sure you understand what I did with 1 over x squared getting to x to the negative 2. They're equivalent, right? X to the negative n equals 1 over x to the n. And remember that and be sure to be able to recognize that, because you'll see this a lot in calculus where you have to use that trick in order to get to the derivative in a form that you recognize. So learn it, be comfortable with it, and be able to recognize it, and it'll be a lot easier for you. Let's do one more example. The derivative of 2 times cosine x plus 3x plus 4 times the square root of x plus 5. Now I encourage you to pause the video, see if you can solve this one on your own, and then restart the video and see how I did it. As always, we know that we can break this into individual pieces, so let's look at it one piece at a time. So the derivative of 2 times cosine x, we can pull a constant out. So 2 times the derivative of cosine x. The derivative of cosine x, that's one of our properties. It is negative sine x. So we get negative 2 times sine x. Be careful here, right? Because it's very easy to forget the parentheses and just make it 2 minus sine x. That's not it. It is 2 times negative sine x, which is negative 2 times sine x. So just be careful there. The second piece, the derivative of 3x, we did, right? We can pull the 3 out, 3 times the derivative of x, so 3 times 1, that is just 3, right? So what about this next piece, the derivative of 4 times the square root of x? First, we know we can pull the 4 out, so 4 times the derivative of the square root of x. Now we don't have a square root property, right? We don't know what that is. So how can we use what we know to solve this problem, right? And again, this is something that you're going to see in calculus quite a bit. The square root of x is the same thing as x to the 1/2 power, right? The cube root is x to the 1/3 power, the square root is x to the 1/2 power. So you need to memorize those little things. So we can rewrite this as 4 times the derivative of x to the 1/2 power. And that, again, that's just the power rule. So we bring down the 1/2 and we subtract 1 at the top, and we get 4 times 1/2 times x to the negative 1/2, which is equivalent to 2 over the square root of x. The final piece, the derivative of 5, is 0, because 5 is a constant. That's easy. And so now we can just piece all of this back together. So negative 2 times sine x plus 3 plus 2 over the square root of x plus 0. We simplify, and we get that the derivative is negative 2 times sine x plus 3 plus 2 divided by the square root of x. Something else to note that we've done so far today, and that I allude to in a lot of my videos, is that the hard part about calculus is the algebra. Take, for instance, when we were trying to find the derivative of the square root of x, right? The hard part is recognizing that the square root of x is x to the 1/2. The calculus is just the power rule, right? N times x to the n minus 1, right? So the calculus part is not hard. What's tricky is using algebra to make our problem look like a formula we know. That's algebra, and that's what's tricky about all of calculus, right? The actual calculus part, taking that derivative, it's just applying a formula. It's not that hard. But the tricky part, again, is the algebra to get it to look like something we're comfortable with. And guys, that's all I got for these basic derivatives. So if you learned something, or if you liked this video, please share with your friends, subscribe, leave a like, and I will keep the math content coming your way.